example 1 asks us to use the equality of exponents theorem to solve 2 to the x plus 1 equals 32. The equality of exponents theorem, I'm not going to bore you with the old math speak here, but in general it tells you that b to some power is equal to b to some other power. Alright, I was going to go b to the b, but that's redundant. So b to a is equal to b to the p, that a must equal p. If the bases are the same, the powers have to be the same. That's all it basically says. As you can see, obviously, that 2 to the x plus 1 and 32 to the first, those bases aren't the same. So if it's telling us to use this theorem, that means that we can make the bases the same base. So 2 to the x plus 1 is fine. In general, if I have a prime number, I'm good to go. If it said 4 to the x plus 1, 4 is 2 squared. You can break things down a little bit like that. 32 is going to be 2 to some power. And if we try it out, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so the fifth power. So if they tell you to use that theorem, you have the ability to do that. All right. So once we get 2 to the x plus 1 is equal to 2 to the fifth, therefore x plus 1 has to equal 5, so x must equal 4. Now, just in case they're a little uglier than that in the homework, because they do that sometimes, right? They'll give you something like that, they'll make something ugly in the homework. Suppose they have 27 to the 2x minus 1 is equal to, let's go 81. And if I try going 27 times 27, 729, it's not 81, skip some stuff, right? But we know that 27 is 3 cubed, and 81 is, it's still 81. 81 is 3 times 3 is 9 times 3 is 27 times 3 is 81, so 3 to the 4th power. So you can get both bases down to 3's. Now we have to use the power rule here. If we take a power to a power, we're supposed to multiply the powers. So it's going to be 3 to the 6x minus 3 is equal to 3 to the 4th power. So again, get to a point where you have both things, the same number raised to a power, and then you can say power 1, 6x minus 3 is equal to power 2, 4. So 6x equals 7, so x is equal to 7/6. If you're using this theorem, I expect you get an exact answer. If it's a whole number like 4, great. If it's a fraction, be a fraction. Don't give me decimal approximations on these problems. Always give me exact answers on those. And again, that's probably as challenging as they're going to get. You're going to have to modify both numbers down to a smaller power, or to a smaller base to get them to be the same base. But they're all going to be pretty much like that.